We can know the trajectory or the path that an object will take if we have an expression for its coordinates, x and y, at any time. So if we know how the coordinates vary with time, then we can also work out the velocity and acceleration. So if this is the trajectory, we differentiate with respect to t to get x dot, y dot, which is the velocity, and then differentiate again to get the acceleration, x double dot. Let's look at an example of a ball thrown up in the air with initial speed v vertically and u horizontally. So it follows this trajectory. We can write this trajectory as x is equal to ut vt 1 minus gt over 2v. And because it's written in terms of t, we can differentiate to get the velocity, which is u v minus gt. And then we can differentiate again to get the acceleration, which is 0 and minus g. This is what we expect because the only force assumed to be acting on the ball is gravity, and therefore it can only have acceleration minus g. If x is the displacement, then we can also work out the distance travelled, s. At any time t. And this distance travelled is also known as the arc length. And we have a formula for the arc length. So the arc length is given by the integral of 1 plus dy by dx squared, all square rooted, integrated with respect to x. And if we know x and y in terms of t, we can equivalently write this as the integral of x dot squared plus y dot squared, all square rooted, integrated with respect to time. So let's look at an example of this. If we've got a different displacement, a different trajectory, and it's given by x is t, then we can work out the distance travelled at any time. So x dot is equal to d by dt of t, which is 1. Y dot is the same. And we can work out the distance travelled as the integral of the square root of 1 squared plus 1 squared dt, which is the integral of root 2 dt, which means that after t seconds, the particle on this trajectory has travelled a distance of root 2 t. So we can plot this trajectory. At time t, it's moved t along the x-axis, and it's also moved t along the y-axis. So this is the path that it takes. It's here, and it's travelled a distance root 2 t.